All right, AGS1. Today we're going to talk about section 9.1 and 9.2, and we're mainly going to talk about how you would describe data sets. So we're going to be taking raw data, putting them in different representations, and then talking about how you can describe those with new vocab. Essential question of the day: what can data representations tell me about the data set? So we're first going to start with an example. This example are the calories in cheeseburgers from different fast food chains. So there was like McDonald's, In-N-Out, Five Guys, Burger King, lots of different fast food places, and each of those represents the calories that their particular cheeseburger has. The first thing I notice about this data right here is that it is not nice. It's not in any particular order. So at a certain point, we're going to order that. But before we order it, we're going to make a histogram of the data. So remember, a histogram is kind of like a bar graph that doesn't have gaps in between the bars. And to do that, to make a histogram, you need to decide on class intervals for the x-axis. So in general, how many intervals you have is kind of up to you as a statistician. The rule of thumb with intervals is like, between 4 and 7 or 4 and 8, somewhere in there. You wouldn't want to do 3, that's kind of boring, and you wouldn't want to do like 10, that's a lot. So somewhere in between there. Now, once you decide on how many intervals you are, you have to decide on how wide those intervals will be. So first thing I want to do is show you guys how to decide the width of those intervals. To decide the width, we first need to look at the smallest and biggest number, or the minimum and maximum. I spot a 310 right here. That is the smallest number, so this is our min. The biggest number, what do we get? I think 720, correct me if I'm wrong, this is the max. So to be able to find your intervals, how wide they're going to be, you take the range, which is essentially the bottom minus the top, or the top minus the bottom, 720 minus the 310, and then you divide by how many intervals you want. In this case, I am going to say I want 6 intervals. So if you take 720 and subtract 310, you get 410, but then if you divide that by 6, you get, and so I just chose 6, so I want 6 intervals. It's about 68.3. So I'm going to make my intervals about, well, not about, they're going to be exactly 70. So I shouldn't do a wavy, I should do just a regular. So we'll say that they are intervals of 70. So since the bottom number is around 300, like you could start at, 310 and go up by 70, or you could start at 300. Like, it's kind of up to you. I'm going to start at 300 and go up by 70. So the first class is going to be 300 all the way up to, the next class will start at 370. So that means we go all the way up to 369 calories for the first interval. Add 70 to 370 and you get 440, which will be the beginning of your next interval. But then you need to back it off one to be the top of the interval before that. Add 70 to 440 and we get 510, which means we'll go up to 509, and the next one will start with 510. So we have 1, 2, 3, 4 intervals so far. This one will go up to 70, so that's 580, but back it off one, so this is 579. And then this is 580 up to 750, which is 749. And then I believe we're above the data. How come there's... No, Jolly, come on. 580 plus 70... is 650. So this is 649, not 749. So then this is 650 all the way up to 720, which is 719. And then last one, 720 up to 790. So count them up. We got 1, 2, 3, 4, 5, 6, 7 intervals. I think it's because the last one, like, it ends barely on a 720, so that last interval is only going to have one Like it went just close enough to 720, but not quite. So we could have adjusted that. Like if we had started at 310 on the last interval, would have got it. It's because I backed it up. You guys, it'll still work out. But we have 8 intervals now. That's fine. Now I need to go through and count the frequencies of how often these things are occurring in the data set. So if I look through the data, and I'm going to use a different colored marker for this, 310 is my first one. So I'm going to cross that off. I guess I could use the tally thing that Miss McNeely was showing you guys. Like if you want to do a little tally to keep track. Let me see, there's 1 in the 310 to 369. What's the next one? The next one's 470. So let's see, there's 2 470s. So a 470 here and a 470 here. And I need to go all the way up to 509. And there's also a 480. So that meant that there was 0 numbers in here, and then there was 3 in this data set. So there was nothing in this range, and then from 440 to 509, there was 3 pieces of data that I've crossed off. Then the next number is 510, which falls into this. So then we go all the way up to 580. So let's see, we got 510, which is 1, 540, which is another. Where'd you go, 540? Oh, there. So that's 2. And then there's a 550, that's 3. I'm still under 579. 560, that's 4. And then the next one would be over. So that's 4 tally marks here. Then from 580 to 649, I believe there's only 1 in the data set, and it is 625. So there's just 1 here. Now we go up from 650 to 719. So there's 3. It's 660, 670, 680. So that's 1, 2, 3. And then the next one would be over. So there's 3 in there. 1, 2, 3. And then 720 to 790. There, of course, is only this 720 right here. So we'll take care of that. And then, so the frequencies would be 1, 0, 3, 4, 1, 3, 1. A quick total of these, like if I want to total this, there's 1, 4, 8, 9, 10, 13. Now, I want to go back and make sure there are 13 pieces of data. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes, I got them all, you guys. Such a long process, and it's so easy to make a mistake. So that's why you should always kind of count to make sure you got them all. So those are my frequencies. So we're going to take this table, which is a frequency table, and then use it to make a histogram. So we'll go down here to make a histogram out of this. Notice on the x-axis that I have my calories starting from 300 all the way up to 790. And then on my frequency side, I have no tick marks yet. The reason I'm doing no tick marks is because I needed these numbers right here to be able to decide how high. Because I wouldn't just take this side and go up to like 20 or something like that. Because look, the numbers don't get very big. They only really get up to 4 is the biggest one. So I think here we can go like 1, 2, 3, 4. Because nothing is above 4. The first interval here, 300 to 369, has 1 piece of data. So I'm just going to make my bar start at 300, and then there's 1 piece of data here. We can color that in like Miss McNeely did. The next interval, from 370 to 439, has nothing, so I make no bar. 440 to 509 has 3 pieces of data, so let's see. There we go. Now, I know we said histograms don't have gaps, but it's okay to have this kind of gap when there is 0 data points in between those two. So that gap is okay. Then from 510 up to 579, we have 4 pieces of data. Ooh, the biggest, tallest part of our histogram. And then the next one only has 1. and then jumps up to 3 from 650 on, all the way up to 3. And then the last one only has 1. Okay, nice. We made a successful histogram. And it's okay that we do have that gap because there was 0 from there in that range. Now we're going to take this and make a box plot with the data, which is the main thing we did last time. The thing about a box plot is they need to be in order. So I took the data, the cheeseburger data, and put it all out in order right here. Now, the first thing you need to decide with the 5-number summary is how many pieces of data you have, which we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, to find the 5-number summary, you first of all, you have 2 of them right off the bat. This is the min, and this is the max. So the other 3 are lower quartile, upper quartile, and the median, or Q1, Q2, and Q3. So to find the median, I'm going to use the cross-off method, where you cross off numbers from the sides to find the middle. So cross off a set, cross off another set, cross off another set, cross off another. So there is one number right in the middle, 550. This is our median. Get rid of my crosses, because we're going to need to cross again. One thing to notice to check yourself is that this number of data and this number of data should be the same on either side. So like 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Oops. Okay. Now to find the lower quartile, you just look at the lower half. And the lower half, not including the median, has 1, 2, 3, 4, 5, 6 pieces of data in it. So you can use the cross-off method again, where you cross out a pair, cross out a pair. Uh-oh, I crossed out all the pairs, which means the middle of the quartile 1, Q1, is going to be the average of those 2 numbers, which if you add them together and divide by 2, you get 475. If I do that same process with the upper half of the data, cross, 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 it should happen again, where the middle, they both get crossed out, just the same way that happened with the lower half. Now, that means our upper quartile, or Q3, is going to be halfway in between those 2 things, so 665. There's our 5-number summary. 1, 2, 3, 4, 5. Let's take that 5-number summary and translate it into a box plot. Remember that you put, well, let's start with Q1, Q3, and the median. You just put bars, or vertical bars, where these things occur. So right above 550, I'm going to put a bar. Right above 665, I will put another bar, so that's halfway in between these 2 things. So here. And then the lower quartile is 475, so that's halfway in between these 2 things. And then you make your box. So this was Q1, this is median, this is Q3. Now, the min and the max, we will put as little whiskers on the end. So let me see, 310, I'm going to have to estimate, is probably around here. Put a whisker, connect it to the box. And then 720 is the max, and that's like around here-ish. We put another dot here. Remember that each of these chunks is 25% of the data, so it's like 25, 25, 25, 25. It's split up into quartiles is another way to say that. Now, sorry, I didn't leave myself room for this. Just real quick. Oh gosh, Charlie, come on, pull it together. Let's scoot this down just a little bit. Some people might look at the first piece of data right here, the 310. Like if we go back to up here, do you see how this, like the 310 is kind of pulled away from the data? Some people might say, well, that's because it's an outlier. It's not connected to the rest of it. Then there's this question of like, well, how far away does it have to be from the data to be officially considered an outlier? So a quick note about outliers. If you want to figure out where the actual cutoffs are, there's these things called the lower boundaries and the upper boundaries. So the lower boundary is Q1 minus 1.5 times the IQR. Now, a quick note about the IQR. This stands for the inner quartile range. So the inner quartile range is Q3 minus Q1. The upper bound is Q3 plus 1.5 times the IQR. So here's the thing about outliers. Outliers, any number in the data set is an outlier if it's above the upper bound or below the lower bound. So for my data, from the cheeseburger data, let's see, the Q3 was 665 and Q1 was 475. So Q3, 665, and Q1 is 475. So the upper bound, which I'll just call the UB, would be Q3, which is 665, plus 1.5 times the inner quartile range. Now the inner quartile range is the third quartile minus the first quartile. So if I grab for a calculator right now and do 665 plus 1.5 times the inner quartile range, which is 665 minus 475, I get 950. That means any data point above 950 would be considered an outlier for the cheeseburger data. But there's also numbers that could be too low for the cheeseburger data and be considered an outlier, but they have to be below the lower bound. So I also have to compute the lower bound, which is 475 minus 1.5 times the inner quartile range. So let me compute that on my calculator real quick, which is 190. So because the lower bound is 190, that means any number below 190 would be an outlier, and any number above 950 would also be an outlier. So if I go back to my data, 310 is not an outlier. Even though it seems pretty far away from some of the data, it's actually technically not an outlier in this situation. We're going to look at 6 different histograms, and I'm going to teach you guys some vocab about how to describe these histograms. So first thing is if you look at this graph right here, do you see, we don't have to use numbers in this case, it's really just about looking at the shape of it. Do you see how it's pretty flat? So like, you know, it's not perfectly flat, but it's kind of flat. The way you talk about this is that we say this is uniform. Uniform data. It's very even, in the grand scheme of things, it's pretty evenly spread out. Now, if you look at the shape of this, like over here, the shape of this first one was flat. Now let's look at the second graph. The second graph, if you kind of trace it, looks kind of like a little mountain or a bell curve. Wow, shaky on that side, Jolly. There's 2 ways we can describe this graph. The first one is symmetric. It's symmetric because you can kind of fold it over this line here, and this side will kind of match up with this side. Doesn't have to be perfect, but just, you know, in the ballpark. The other thing I notice about this is that it has one bar that's at the very, it's the highest bar. There's only one bar that's the tallest. So we call this unimodal. Now, modal, like the word mode is right in there. It's because if I was given just this graph right here, this range would be the mode, or whatever number this is, because there's the most data occurring between those 2 points. So that's, mode is the most, so that's the most right there. But there's only one bar that's the most in this, so we call it unimodal. Una meaning one, so it's one mode. We'll see another example in a minute of something that's not unimodal. This graph. If I look at the shape of this graph, see how it's very much pushed to the left? I realize that intuitively you would want to say that this is like, it's pushed to the left, which is true. But in terms of skew, we're going to say this is skewed right. Or some classes might say a positive skew. The reason is that because the side that is stretched out, where the tail of the data is on the right-hand side. So because the stretch occurs in this area, and that's the right side of the graph, you call it skewed right. Same thing with this graph right here. Oop. Do you see how if you kind of trace the outside of it, that it's pushed to the right, which means this side, the left-hand side, is the side that's stretched out. So for this, you would say skewed left. So this graph skewed right, even though it's pushed to the left, and this one skewed left, even though it's pushed to the right. There's a lot of things like that in math that are just backwards of how intuitively they should be. Now, with this graph right here, I meant for these two bars to kind of be on the same level. So if somebody was to ask you, like, what's the tallest bar, or what's the mode of this? Well, you'd be like, well, there's a mode here, but then there's also another one here. This is called bimodal. Just like a unicycle is one tire, unimodal is one mode. Bimodal, like bicycle, 2 tires, means that there's 2 modes. So there's 2 peaks, I guess we could say. The last graph I want to show you is that if you trace this guy, and then there's this gap, and then there's something over here, this is a possible outlier. But like I showed you guys earlier, there is that math process of figuring out where the cutoff would be for outliers. Sometimes just looking at them, you can't really tell what's an outlier and what's not. Okay, you guys, that is all I have for us today. Good luck with the formative. I will help out in the chat.